So welcome everybody, my name is Lehto and I work as a Vaadin expert and trainer with the Vaadin Ltd back in Turku, Finland. And as probably quite many of you know, Vaadin is originally a Finnish framework that used to be called ITML Toolkit, but it was rebranded to Vaadin back in year 2009. How many Vaadin users do we actually have here? Everybody. Oh, great. Well, I have a little introduction to Vaadin in my presentation, just in case that somebody isn't aware what Vaadin is, but let's try to make it interesting also for those who already know about this stuff. So what we'll be talking about today is, well, initially what Vaadin is, but more to the point, how you actually use Vaadin with Java EE7, or not even Java EE7, but in general with Java EE based backend systems. How we will do that is that I'll introduce you the Vaadin CDI add-on, which is the pretty recently released addition to the Vaadin so-called component library. It's not really a component, of course, but more like an integration add-on for the backend systems. Since we're talking about EE, it's of course important to be able to build Vaadin applications with a reasonable structure. So that's then the next thing that we'll look into, as well as the complete architecture of Vaadin applications, or applications running on top of EE using Vaadin on the client side. And as you probably noticed, this isn't really a GWT talk, but since Germany apparently has a lot of Vaadin users, I was for some reason allowed to have this talk here. So thank you everybody for coming. About that introduction, so since we have so many Vaadin users, you probably know what this is. Yes, and Vaadin is of course a Finnish word for a reindeer. And if you'll just tilt the logo 90 degrees aside, or look at my shirt, you of course see the horns of the reindeer. So that was the very cool branding trick that some very elegant marketing office was able to pull back in year 2009. More to the point, Vaadin is still today mainly server-driven UI framework for rich web applications. And just a couple of years ago, it was very trendy to be on the server side. Everybody wanted to avoid JavaScript. There was even a booth at the Java 1 saying that JavaScript, where the actual script part was striked out. But times have maybe a little bit changed, and JavaScript is, with different JavaScript kind of frameworks, becoming more and more popular again. And even though I'm here saying that Vaadin is server-driven UI framework, we're also working on the side of bringing more and more Vaadin features and widgets also for pure GWT developers, as well as, for example, AngularJS developers. So we'll be having another talk this afternoon about how you can combine certain Vaadin widgets better with GWT parts as well as with AngularJS. Just wanted to mention this so that I at least have some content that has something to do with GWT in this conference. Cool. So what Vaadin provides for you is a server-driven framework, as I said, but with the ideas of increasing developer productivity. And how we increase the developer productivity is that the APIs are on more higher level. You have to actually write much less code than you would with GWT, even though GWT has of course been advancing very nicely. I'm not saying that. Also, debugging Vaadin applications can be done with your normal IDEs without the great, fantastic super dev mode that is now also supported in IDEs. But just on the server side, debugging things and using tools familiar to you are of course easier to use than, for example, having to cope with certain kinds of browser debuggers. Another thing that Vaadin provides for you is pretty rich UI component library. So this is just an example of the components available, themed with the new Valo theme that was released with Vaadin version, I believe, 7.3. So Valo theme is something that uses the SCSS, which is the syntactically awesome style sheets, very close to the GSS, but still a bit different. And you can, for example, do SAS compilations with Vaadin to CSS completely autonomously from the actual GWT. So we have a separate SAS compiler for doing the actual compilation. As I also mentioned, of course, the developer productivity is heightened with the, let's say, more high-level APIs, but also the user experience of users using the Vaadin application is by default pretty high, since Vaadin really tries to be very nice look and feel framework with the default settings. So server-side UI, but how exactly? I'll show you very little demo from a live app that'll a little bit better demonstrate what this is really about if there is still somebody who isn't that much aware of Vaadin. Practically what this means is that normally when we reload our web page, we get some resources downloaded from the actual web server. And these resources, for example, contain the actual GWT widget set that contains all the client-side representations of the components. So what this means is that for every Vaadin component, there is a client-side representation that doesn't contain any business logic, but only bits and pieces that are to do with the rendering. And this is the actual GWT part of the whole Vaadin. Other thing that is loaded is the styles CSS that contains the actual Vaadin theme together with all the graphical assets of your theme. And if you're using SAS, the SAS compiler will, of course, compile your theme to standard CSS so that it's compatible with all the browsers. And idea would be that as the application is started, it'll render its content with a thin client-side engine that will read the actual state of the server side and render that using the GWT widgets on the client side. And if I, for example, answer the question and type in my name and press create button, I'm greeted with a notification, "Hi Peter, you have clicked 1 time." And what happens really here is that we're making a post request, AJAX asynchronous request to server that'll contain the bits and pieces that changed on the client side since the last synchronization state. And in this case, it'll mean that a button server RPC was called with a click method, and some other parameters were also sent that are needed to be able to actually know exactly what happens on the server side. As a response to this request of mine, I'm getting back an array of JSON that'll contain the information on what really happened. So here you can, for example, see that a notification is shown with a caption, "Hi Peter, you have clicked 1 time." So I mentioned that there is somewhat high level of productivity and like high-level APIs. So the application that will actually display you this logic is practically written in these lines. So we're having a form layout configured with some margins and spacing, as well as text field and button with the corresponding captions. And since we are on the server side, we can already now use Java 8 features and, for example, Lambda function for the actual button click listener. So once we click the button, Vaadin is able to route back the communication to this click listener so that your duty is only to implement what you want to happen when the button is clicked, but you don't have to consider any of the actual data transportation between the client and the server side, which will, of course, increase the developer productivity. And the click count here, for example, is now something that is stored in the server-side session of the actual Vaadin application per user, and also per UI. So as I have my UI here with the click count, and I have my UI open in the browser, if I open another tab and type something here and click the create, the counter will start again from 1, whereas in the other UI, it's already 2 or 3, and here it's again just 2. So the state is, of course, always preserved by a UI instance. I suppose this is more or less familiar to all of you. Was there somebody who didn't know about this? Please, somebody raise a hand. No. Okay, cool. What about the Java EE then? How many EE users here are? Everybody raise hands, of course. So I'll tell you a little bit about the basics of EE. How dull. As you know, the EE is a collection of Java specification requests, JSRs. And the idea is that the application server implements these specs. So what we'll actually have is a collection of app servers implementing the specifications, maybe a little bit differently, but still, of course, according to the specification. Some servers might add some additional features, which are then sort of features explicitly available only for that one distribution, but still they all follow the same practices that any server that implements the EE spec should follow. As you, for example, know, JPA, Java Persistency API, is implemented, for example, by the Hibernate as well as Eclipse Link. And as another example, I'll be using the CDI today, the context and dependency injection. And for that, there are, for example, 2 implementations, Open Netbeans as well as Weld for the JBoss world. Have you used CDI before? Some have. OK. Hands, not so many hands anymore. That's actually a good sign, since then I really have something to tell to you. Which EE specs do you then know? What are the most commonly used specs? I already mentioned JPA. Everybody have been using JPA at some point. Everybody started with a project where they were given some fancy entities and you were so excited that, wow, it's actually creating a database table for these without having to actually do that with any alter table or create table syntax. Great. What about EJBs? Are you still using them? Of course. EE7 just added new functionality for having, for example, transactional CDI beans, but EJBs still provide very nice remoting capabilities, for example, and just container managed features that are still not quite the same with CDI beans. Of course, servlets. So Vaadin is, for example, on the server side, a servlet-based technology using a stateful session management on the server side. Then JMS is, of course, another pretty important EE spec for message delivery systems. And of course, the CDI, which we will use for integrating between the Vaadin and the rest of the actual EE stack. Since CDI, with its injection capabilities, will give us a very nice way of referencing other EE services directly from the Vaadin layer, if so needed. Then we have some competition. Luckily, these are the bit older versions. So JSF for Java Server Faces for creating magnificent UIs, which are, of course, not as magnificent as Vaadin. For the old timers, of course, the JSPs for really, really template-based nice systems. Bean validation, which is very useful with JPA even today. Vaadin, for example, provides support for bean validation that will allow you to have direct field validations based on the bean validation annotations in your entities. Interceptors, very good with EJBs, for example, to logging and monitoring purposes or whatever you decide to do with them, as well as the JDA, that stands for Java Transaction API. So JDA is very useful together with EJBs, just for example, to provide a clear transaction boundaries between your actual service calls from the UI. Since you always want the call either to be completely successful or rolled back all the way to your database layer. Then some other communication techniques like JAX-RS for RESTful web services, JAX-VS for XML-based systems, as well as JAX-B, for example, to store your entities in an XML format. Well, there's quite a bit of specs, and we have maybe 35 minutes left, so don't be afraid, I'm not going to go through all of them. Which APIs do you think you should know? Well, it says there the parts that are part of your technology stack. Can any one of you say that you master all of the EE specs and you use all of them in your day-to-day work? Yes. Nobody says that. Cool. So that's exactly the point. EE is huge, and we're not expected to know all about that, but only the bits and pieces that are really important for us. And they are important since they are part of our stack. So let's have just a little bit closer look into JPA just to establish the grounds on top of which we then build our great Vaadin UIs. Let's say we have some entity representing a customer. He might have some primary key annotated with ID, and it can be auto-generated. Then we have some other properties, potentially with some additional information available, defining, for example, database constraints, or let's say some other column definitions. This customer entity can be stored into a customer table that JPA very nicely creates for you, and each instance is of course stored per a separate row. Also, the entities can reference other entities by, let's say, one-to-many or many-to-one, many-to-many, any kind of relations. And they, of course, all get stored into separate tables representing corresponding entities. Then the EJBs. They are very useful for business layer services, for creating like clear boundaries between your app, let's say UI layer, as well as then the actual backend service layer. With the EJBs, you can define how fine-grained your services are. You can, for example, make methods that access only certain little bits of the information, or you can make very high-level methods, for example, running some reports out from your system, or any other higher-level abstractions that actually combine a lot of lower-level services. These services can be local or remote, as I already mentioned, as well as the transaction boundaries, since when you're actually making, let's say, a store method invocation to some EJB that will save some customer information, and let's say that you're passing in, for example, 200 customer records, you might wish that they all either get stored or none of this information is stored. And this is pretty free feature given to you by EJBs together with JDA, so that the transactions will actually sort of overlap all the way to your JPA layer together. So let's have a little example of a Vaadin UI connected with some kind of a customer service that could be, for example, a remote or local. The implementation of the actual service bean interface would either be stateless, stateful, or singleton. These are, of course, pretty familiar for everybody. Maybe the latest addition in EE6 was the singleton. That simply means that there is always one instance, and that's pretty practical in the case you, for example, want to customize the locking features, or how different calls are handled inside the bean. And all of these services, doesn't matter how they've been actually implemented, can then talk all the way back to the actual customer database layer on JPA. So this would be an example of a very simple local interface for customer service. Let's say that we want to store a collection of customers, remove collection of customers, acquire all the customers, or find something by the name. So this is practically the level in which you can define how fine-grained your services are. You can do some larger operations, or you can find some particular small part of your data. And this is a great way on defining which kind of services you are actually providing. The actual implementation that reaches all the way to the JPA layer would very easily be able to inject persistence context, so that whenever you invoke a method, it would forward it directly to the entity manager provided by the persistence context. And since we are talking about transactional methods, what this means is that even though we're passing in a collection of customers, if one customer should fail to store, the entire transaction would be rolled back, which is something that not too many, let's say, competitors of Java can do with such a little amount of code. Well, what about the CDI then? This is the really, can't really say new part, but something that was also introduced in EE6, the context and dependency injection. Not too many were using CDI here, so I think this point really concretizes the whole thing. Instead of saying new, you say inject with the annotation. And what this will do is that it will actually ask from the CDI context, from the container, that I should now have an instance of something that is of this type. Can you please provide me that instance? At that point, the container will find a proper object and pass a reference to your injection point. The difference is that if you said new, then you were actually in charge of that particular variable. Your code would actually manage that. But when you're injecting, then you are more saying that there somewhere is an object, please give me a reference to that. Well, what's the point? This very nicely decouples the code and lets container manage your dependencies through CDI contexts. So when I say CDI contexts, it practically means scopes. There are, by default, 3 kinds of scopes available, which are meaningful when, let's say, doing Vaadin development. There are things like application scoped. One good example could be that instead of for every user of your application loading, let's say, some configuration separately, you might have a configuration object application scoped, which means that everyone using this configuration would actually reference the same instance of that without having to instantiate another object per every separate user, saving you memory. Session scoped is something that can be bundled, for example, with HTTP session, meaning that all the users, doesn't matter how many UIs they have some objects bound to session scope, meaning that in my previous example where I had my different browser tabs for Vaadin UIs, if I had something in session scope, the different UIs would still share this same instance per user session. Request scope is something that can be, for example, used together with single HTTP requests. I promised to tell something about the Vaadin CDI add-on. That'll add 2 additional scopes which are specific to one UI or one Vaadin view. I'll tell you more about those in just a second. Here's one example. Let's say that we have a UI scoped app UI, which is our Vaadin UI. And since this is now a CDI managed bean, since we're using this with Vaadin CDI, it means that we can have additional injection points, for example, our EJB services. And since this is a managed bean, it is actually able to read the annotations and say that, okay, at this point, please give me a reference to customer service, which it would be able to inject from the actual EJB container, or as a proxy object to that. The customer service can then, of course, be a stateless service bean, which might have references to other EJB beans. Similarly, our app UI might, for example, have a main menu, which would be just another CDI managed bean, also UI scoped. So it means that for every browser tab where we have one Vaadin UI, for every tab we would also have an instance of the main menu. We'll go in a bit more detail in just a couple of seconds. So how do you then more practically use Vaadin CDI? Vaadin CDI's purpose is to allow using Vaadin UI, Vaadin view, and Vaadin components as managed CDI beans. And a little bit reiterating here, what managed bean really means is that it's something that is handled by the container, not by you. You get a reference to that by saying inject, not with the new. Allowing you also to use, for example, the @EJB annotation for EJB references. And reference any other EJB EE objects very easily. How you would really do or implement a Vaadin UI with the Vaadin CDI would be that you normally extend from your UI, abstract UI class, and say @CDI UI, which is a mechanism that tells Vaadin CDI that whenever somebody requires a web page that has a Vaadin application that displays a certain UI, provide him this particular UI object as an UI scoped instance. You might also see these markings here, which are practically empty. That's a way for you to bind different UIs from your URL to different actual UI instances without having to, for example, use the Vaadin servlet configuration annotation for defining which UI you want to use with a specific servlet. So this will really give you a nice mechanism on very little amount of code with just one annotation, use multiple different UI types with your application, which are still managed CDI beans. And since it's now managed CDI bean, you can just say that at inject and inject different references that might have their own scopes defined. For example, as the main menu was UI scoped, for every UI instance, you would get own instance of main menu. But let's say that your user was session scoped. All your UIs would share the same user instance, who might, for example, be the currently logged in user. Just to explain the difference between the UI scope and session scope, we can, for example, consider this diagram where we inject our main menu, some view manager, and the currently logged in user. If we have multiple UIs, we will also have multiple UI scope instances, one per UI. So you can sort of think of the scope as a map that maps certain other objects per one UI. What you can see here is that the session scoped user didn't get any more boxes around it, meaning that the same instance of the user would be shared between all the app UI instances. And for example, considering the application scope, if you had multiple users using the app at the same time, which of course had their own HTTP sessions, the application scoped bean would still remain as singleton for that application. Did somebody understand something? You're still not even sleeping. Okay, so it wasn't probably that bad. The reasoning for the actual UI scope and the need for that comes from the architecture of Vaadin. So at the top we have Vaadin servlet, and for one Vaadin servlet we can have multiple HTTP sessions, one per every user of your Vaadin application. Inside HTTP session, the actual state of the Vaadin app is stored into an object called Vaadin session. So one Vaadin servlet has practically as many Vaadin sessions as there are HTTP sessions. There are some possibilities that you can have more than one Vaadin session object per one HTTP session, but that would require different kind of deployment configurations of the actual servlet. And of course, one Vaadin session will contain multiple UIs, one per every browser tab. And this is, for example, a major difference between Vaadin 6 and 7, since Vaadin 7 automatically creates you an UI instance per tab, but Vaadin 6 just used to use the same instance, and if you changed something in different tab, you would get out of sync exception. So this is something that has been evolving in the framework since the 6th version. So UI scoped is something that specifies certain beans per one UI instance. And when you're saying CDI UI for your UI, that is also a stereotype that means that the actual UI is always by default UI scoped. So you get that without saying anything. The place when you should UI scoped is when you're, for example, creating some components that you want to have as a UI specific instance, say the main menu. So the UI scoped is the mapping of certain beans to a CDI context that is bound per one UI. And of course, you can use that with the @UI scoped annotation. Well, how would you use that? Let's say that we have the main menu that you might extend from custom component defining some component composition. You use the UI scoped annotation, and what's the benefit of that is that, let's say in the main menu, you want to use CDI event bus mechanism to tell the application that you're navigating into a different view. Quite often I think that without CDI, let's say you had an application in which you wanted to change more than just the current view in the navigator's view area. You might want to change some parts of the actual header or footer, whatever in your app, and at that point you would actually have to reference these components. With CDI, you can fire event into the event bus, in this case something called navigation event, and you can listen for this event in all classes, all objects that are part of this same UI scope. So this way you could actually navigate in your application, even so that you had multiple instances of the UI open in the same browser, but still so that the actual events would only be delivered inside a one particular UI instance. So how would you then use CDI to observe these events is even more fancy. You'll just create a method with any name you want. You use @observes annotation for the method parameter, and you just listen for the same type of an event. Doesn't matter where this code is, as long as it's part of the same context, same scope, it will be heard when the event is fired into the event bus. Okay, we have maybe some kind of grounds for using CDI. We realize that with that we can inject other beans, probably or possibly EE references, EJBs, into our apps. But when we start doing that, quite often we might find ourselves writing code that becomes pretty unmaintainable at some point. So what's your favorite food? Do you like spaghetti? Have you? Yeah. How many of you have seen spaghetti code? Yay. How many of you have been in a project that doesn't have any documentation? No best practices whatsoever, and then you find yourself as the only developer in the project since everybody else figured out that let's leave the sinking ship kind of an approach. So if we use best practices, some commonly known patterns, we can actually clean our bad code. What I'll be telling is the MVP, Model View Presenter pattern, but before going there, let's just take a brief look back into the history of MVP. MVP actually originates already from the late 70s, where it was initially called Model View Controller. And Model View Controller, of course, today still exists also in web applications. This, of course, wasn't for web apps at that point, but certain kind of a base of all the different variations. It was first introduced in the Smalltalk 80 programming language as a pattern for writing cleaner code. So apparently the programmers back in the 70s already had the similar problems. In MVC, the controller was sort of a mediator between the end user and the application. So the controller would listen for the inputs that are coming from the user, mainly back in the 70s from the keyboard or like physical device, in a sense that they were able to decouple the control from the actual logic. Well, during the 80s, a company called IntelliJ invented, let's say, a simplified model of MVC that they called Model View Presenter. It was heavily, of course, influenced by the Smalltalk 80, and it was a bit more complex than the triad of MVP that we have today. It also contained things called interactors, commands, and selections. The idea was that with certain selections of data, you would run certain commands, and your interactors would actually find some kind of user input events on top of which they build the selections for commands of data. So this is somewhat complex. Idea there was still fundamentally different from MVC, as the presenter in this case would orchestrate the structure but not the input. Well, that's too complex. It'll just create more boilerplate flush. So then there is a thing called Dolphin Smalltalk MVP, which is a simplified version of IntelliJ MVP. And idea with that is that View handles events by notifying presenters. And this actually works pretty cleverly with Vaadin and, well, of course, any kind of a web-oriented framework, since views are the places that contain, for example, our listeners, click handlers, any kind of event listeners that we might want to implement with our Vaadin applications. The fundamental part here is that the presenter handles the logic, not the user input control. So as I said, the views will listen for the events and pass this information to presenter. One obvious bonus that you get from this is that as long as presenter is the place where you handle the logic, you can actually test that logic without having to have any web framework or any framework whatsoever associated with that, since you could very easily, for example, mock away the views which are bundled with the presenter through some kind of an interface. So yeah, let's use this and see what kind of applications we can build with that. UI layer MVP targets the clean code best practices, so-called solid principles. Have you heard of solid principles? And still you write sometimes spaghetti code. Yeah, well, so do I, so no problem. This is probably the most familiar of them. Single responsibility principle. It says that class should have only one reason to change, which also states that class should have only one responsibility that it should take care of. Just because you can put all your features in one class doesn't mean that you should do that, since it becomes very hard to test, very hard to maintain, and you start actually building structures inside your class to manage different features which would essentially be part of different classes, providing these different responsibilities. Another solid principle is open-close principle. So keep something open for extension, but closed for change. Let's say you want to add additional feature. It's not very nice that you'll have to refactor your old class completely just to be able to support the new thing. So you don't really have to do an open gesture just to be able to put on a coat. Bit horrific picture, but anyway, idea is probably clear. Don't change everything every time when you add a feature, but instead design your classes in such a way that you can just add more classes. A good example would be, for example, some kind of a, let's say very simply, some shape drawing canvas. You want to draw some shapes to your canvas, but you would have to have some kind of a if logic that if the shape is this, then you will draw it like that. If the shape is that, you will draw it like this. Instead, make an abstraction of shape that implements a draw method. And whenever you add a new shape, you just add a new class of the shape that has its own implementation of the draw method. Then, of course, the dependency inversion principle depend on abstractions, not concrete things. So instead of really soldering your electrical plug, consider some other alternatives. And this is exactly what, for example, the CDI will give you. You can just inject based on an interface type, and the container will find you a proper instance. So your application will only depend on interfaces, not on concrete implementation of, for example, your main menu. Well, there are many variations of MVP available. Here's the most common one, the triad, where presenter tells views what to do, views tell presenter that some event has occurred, and presenter might update a model that the view renders. Well, for the sake of simplicity, we'll sort of ditch the model for now and just concentrate on these two parts. It's very common to have an interface of the view, since we don't want to depend on concrete things, but just abstractions. So the presenter should only know about the interface of the view, and some implementation, possibly written with Vaadin, could then actually implement your views. So the normal case would be that you have some kind, let's say, an editor view with a couple of buttons and some field group that will map different fields, which you then want to store to your backing data source. There's some kind of a click listener, and depending on which button you clicked, some action will happen. This is not MVP. This is the starting point of the code that you had to do very quickly that will, at some point, become a mess. So to prevent that, we introduce a presenter that has save button clicked and cancel button clicked methods, which actually take care of the logic, what should happen when a user clicks either of these buttons. And just to make it complete, the presenter knows the view only by its interface. So the view provides methods on the interface level, which are the high-level so-called business methods that the presenter can access from the view. And then the actual implementation will only implement these methods. So for testability, for example, you might just mock away the view and do assertions that correct things happen when some methods are called from the presenter, since you could even create a JUnit test that'll just invoke these methods from the presenter without having to have any kind of a UI really attached to that. Well, benefits of MVP, of course, simpler classes by the single responsibility principle. Instead of having the rendering as well as all logic in the same class, separate them to two classes. Of course, the critique is that you will get more classes, and let's say that in simple applications, there is not necessarily even that big of a benefit. But have a system that has, let's say, 800 views. I've been in one. Without MVP, it's suddenly very, very complex mess of things. So the complex UI logic becomes separated from the actual rendering logic. And logic becomes much more easy to test with the dependency inversion principle, because you can mock different dependencies in your tests. Let's just have a very quick look on the actual complete architecture, what it would look like if you built Vaadin application with MVP on top of Java EE. This is possibly the most common kind of layered architecture of any system. So here you practically have the client browser, some kind of a server-side UI with the view and presenter forming the MVP triad, as well as a HAB-based business logic unit that can be deployed on some other server if so wanted. And this business logic will store data to the JPA persistency layer, or any kind of persistency that you want to use, not necessarily JPA. And if we start from the view, it would actually be something like this. So you have an interface of, well, the mentioned customer view, and you might have some kind of an abstract interface that allows you, for example, to generically type the presenter. So the customer view is expected to be used with a customer view presenter. This interface provides you methods that the presenter can call from the view. So these are the high-level methods that the view should be able to do when some things happen in the presenter. Let's say that presenter wants to tell the view that please populate these customers to some kind of a data grid, open some kind of customer editor for a specific customer, close the editor, or maybe remove the currently selected customer from the selection. The presenter part would be implemented in such a way that it would be extended from some abstract presenter, which purpose is again to do the generic typing for the customer view interface, not the actual implementation, but just the interface. And since we're now talking about views, we quite often use them together with Vaadin Navigator. And since they are like separate units inside the Vaadin UI, it makes sense to view scope the views and the presenters. Meaning that if you want to, for example, fire some events inside the view, which should not affect the whole UI, you might be able to control them better by providing the view scope annotation that defines the presenter inside a particular view's scope. Well, since this is now a managed bean, the presenter has a role that it takes care of the customer service communication. We have some kind of an interface for our customer service that is able to provide us the customers, that is able to store and remove customers. And with JDA, it's transactional. So if something goes wrong, it's not the responsibility of this layer, but the customer service to actually react to that and then potentially roll back the transaction. So when, for example, the view is entered, we might say that customer service get all customers and ask our view interface to populate the data grid with these customers. And let's say that something went wrong here, we might just have this wrapped in a try-catch block and say view show some kind of a notification that customer loading failed. Since then in here, you would actually have the logic, not in the view. And what I mentioned about the events with the observes annotation, whenever something happens in the view, we have, for example, click listeners for our view buttons in the view layer. And whenever something happens, we might fire a CDI event that we observe in the presenter. So when, for example, customer becomes saved, we do some logic in the presenter that potentially, for example, invokes the customer service, does some validation, anything that we want to do. So this logic becomes moved out from the actual view, and if you wanted to test this separately, you could just now invoke these methods in your tests. Well, then we have the business logic layer. So the customer service could be either remote or local interface that is now able to provide the high-level business methods for managing our customers. So we might store customers, remove, get all of them, or get by name. The implementation could be stateless, EJB, just to make it highly scalable. We define the transactionality attribute that says that whenever this method would be invoked, a transaction would be required. And even though we, inside of the method, would, for example, invoke another method from this EJB, it would still be part of the same actual transaction. Again, we might inject the entity manager through the persistence context with some persistence unit and just forward all the interactions directly to the entity manager. Lastly, we have the persistency layer. So we have our fancy customer entity with magnificent two properties, the ID and the name. And we would define the customer in the persistence unit, or we don't really even have to do that, since, of course, the listing of the entities isn't necessary, but just to make it more clear for you what this is, I've just listed the customer entity here. The point being that the transaction type should be JDA, not resource local, because then with this, you don't actually have to begin, commit, or roll back the transactions manually. But since the whole persistence context is injected here, you can just sort of for free get the transaction handling all the way to the database layer. How would you get started with this thing? If you're using EE, the recommended official way is to use Vaadin CDI add-on. You can find a lot of tutorials and blog posts from the Vaadin.com, and you can use this in your project with these mentioned group and artifact IDs. Currently, it's distributed in the Vaadin's own Maven repository. If you, for some reason, haven't yet tried, you can download the Eclipse plugin for your Eclipse IDE for Vaadin. IntelliJ already comes with built-in support if you're using that. And also for the Netbeans, there is a Vaadin plugin available. Of course, these plugins are not necessary on developing Vaadin apps, so you can just use pure Maven as well. Everything that I've said so far about the customer app is actually available from GitHub under my user with the CDI example. So if you got interested, you might want to see how to use Vaadin with CDI from right there. At that point, would anybody have any questions? So what did we learn today? EE contains tons of specifications. You don't want to know all about them, but just the parts that are actually important for you. Vaadin is, of course, great component-based way building the UIs, and since you're already all using that, I have nothing to add. Combining Vaadin with EE works, of course, best through the CDI, or if you happen to be a Spring user, then with Vaadin for Spring add-on that does exactly the same job as Vaadin CDI. And to be able to write maintainable code, it's recommended to use some of the best practices. Not necessarily the whole MVP, but at least the solid principles which will guide you making the code that doesn't even have to be documented, but still it's clear for your colleagues. Last point, we have still about maybe 200 books at our booth that I'm not going to carry back. So please go to our booth, pick the book, or if you want, download it from online. And also, don't forget to rate the presentation at the GWT.create.com/agenda. Thank you.